The next topic in separations is chromatography. And the first technique we're going to learn about is thin layer chromatography, or TLC. This type of chromatography is used most often as a characterization tool. It's a way to assess the purity of a compound or identify how many components are in a mixture. For example, if you had a mixture like this with 3 different components, a chromatography experiment could be used to resolve the mixture into the 3 individual components. And the type of chromatography we are going to be using is based off of differences in polarity. So let's look at the kind of overall picture of how this technique works. For thin layer chromatography, you are going to use a thin plate that is backed with plastic or aluminum. And because we will be carrying out what's called normal phase chromatography, the aluminum or plastic will be coated with a polar material. We'll talk about that a little bit more. And we will take the mixture that we're trying to characterize and place a sample of that at the bottom of the plate. We call the solid material that is coating the plate the stationary phase, and then we will introduce a liquid at the bottom of the plate, and we're going to call this the mobile phase. Typically, the mobile phase is going to be something that is less polar than the stationary phase. And because of the capillary action of the plate, the solvent at the bottom is going to start to travel up the plate, and when it comes into contact with the mixture, the different components are going to travel at different rates as they progress up the plate. The most commonly used stationary phase, and the one that we will be using, is silica or silicon dioxide. And you can see that at the surface there are a lot of free hydroxyl groups, and these are really polar and also available for hydrogen bonding. Compounds that are not significantly polar are not going to interact very well with the silica. Somewhat polar molecules will have some interaction with the silica, and very polar molecules, especially those that can hydrogen bond, will interact very strongly with the silica. And so when this less polar solvent comes along, the components in this mixture are going to interact differently with the solvent depending on how well they are interacting with the stationary phase. The 3 different types of components are going to interact differently with the mobile and stationary phases. So the less polar components are going to interact much better with the mobile phase, and the more polar components are going to interact much better with the stationary phase. As the mobile phase, the solvent, moves along the plate, it's going to carry with it most readily the less polar components in the compound. So they're going to start moving up the plate. The very polar molecules over here are going to interact very strongly with the silica, and the solvent is not going to disrupt those interactions very well, so they're going to pretty much stay put or move very little. And then the ones in the middle are going to interact both with the silica and the solvent, and so they will be moving along but at a slower rate than the nonpolar compounds. For example, this nonpolar pentane molecule here is going to interact much better with a less polar solvent than it would with the really polar silica stationary phase, and so it will be moved along quite readily by the mobile phase. On the other hand, the really good hydrogen bonding carboxylic acid is going to interact very well with the silica, and the solvent is going to have a difficult time disrupting those interactions, and so this one's going to start lagging behind. And then the ketone, which can interact with both the stationary phase and the mobile phase, will be somewhere in the middle. So the idea is that the mobile phase will travel up the plate. The most polar component in the mixture is going to interact the strongest with the silica, and so it's going to start lagging behind, while the least polar component is going to be interacting very little with the stationary phase, but very well with the mobile phase, and so it's going to be towards the front of the solvent.